To answer this question, we first need to find the individual component forms of CD and BA, and we can start out by finding CD. If we label the x and y components of C and D, then the vector CD is going to be the difference between the x and y components of D and the x and y components of C. So we're going to D, so we place those components first, and then we subtract where we were coming from, which are the components from point C. So we're going to have 0 minus 5 for our eventual x component, and negative 1 minus 0 for our eventual y component. And if we work that out, we figure out that the individual component form for the vector CD is negative 5, negative 1. Now we can repeat the process with the vector BA. We want to label our points B and our points A. And again, we're moving from B to A, so we take the values for A and we subtract the component values for B. So we say XA minus XB and YA minus YB. And the only reason we're not using X1 and Y1 is because we'd have to do it twice, and that could be confusing when we have 2 points that we have to set up. So this is going to end up giving us negative 2 minus 3 and 1 minus 4. And if we clean that up, we'll have the individual component form for the vector BA, which is negative 5, comma, negative 3. From here, we want to subtract these two vectors. And the way that we subtract vectors is we subtract their individual components. So we're going to subtract the x components and the y components from CD and BA. So since we're starting out here with CD minus BA, we start with the components from CD and subtract the components from BA. So the x component of CD is negative 5. We're going to subtract the x component of BA, which is also negative 5. And then we'll take negative 1 and subtract negative 3. And if we work all that out, that will give us our final answer for vector CD minus vector BA in component form, which is 0, 2. Now if we want to find the magnitude of that vector that resulted, we treat each of those components, each of the pieces in that component, as the leg of a right triangle, and what we're looking for is the hypotenuse. So we can solve for the magnitude by taking the square root of the x component squared plus the y component squared. So that'll give us the square root of 4, and when we simplify that, we'll have our final answer, which is that the magnitude of this vector is equal to 2.